Hi, you guys. So, welcome to your video notes for section 721. So, get this out if you don't have it out right now. We are switching gears in this section to start talking about triangles, review some of the tools we have, and learn a couple new tools for finding missing parts of triangles. So, before we even begin, get this out. Make sure you have a calculator handy. And I just want to challenge you to engage. Don't just write things down mindlessly, but stop and think about what I'm doing. If you need to pause the video, if I'm moving too quickly, pause the video. So take advantage that you can stop, think, rewind, rewatch if you need to. All right, so let's start by talking about what tools we already have when it comes to finding information or missing information about triangles. So one of the most basic things I want to talk about is just what we know about three angles in a triangle. So one of the more simple topic or facts that we know are that all three angles add up to 180 degrees. So if I found the measurements of angles A, B, and C, those would always in any triangle add up to 180 degrees. So that's helpful to us in finding missing angles sometimes. Aside from that, most of the tools we have right now are always related to right triangles. So if I make this A, B, and C is my right angle, so that means the side opposite is little c, side opposite of A is length A, side opposite of B is length B. All right, so this is how I'm labeling my triangle. Let's talk about what we know here based on this right triangle. So first of all, we have the Pythagorean theorem, which is super useful in finding missing side lengths if we had enough information. And that is that the side length of A squared plus the side length of B squared equals the side length of C squared. So that's one fact we know. A squared plus B squared equals C squared. That's one that we will certainly use. And then we also have all of our trig ratios. So if I said this was angle X is related to these different side lengths and the ratios of these side lengths by the trig ratios we know. We use SOHCAHTOA as a helpful way of remembering those trig ratios. So I know that the sine of X is the ratio of the side length that is opposite. So here's X, the ratio of the opposite, so that would be B, divided by H, the hypotenuse. So opposite B divided by hypotenuse C. The sine of X is that ratio. So if I have those two side lengths, I could apply the inverse sine, take the inverse sine of both sides, and then I would have the value of that angle measure X. We also know cosine. So cosine is the C. Cosine of X is the ratio of the adjacent side. So if this is X, adjacent means next to. It's not C. C is not the adjacent side because C is always the hypotenuse. So A, adjacent, divided by hypotenuse, C. So A over C, and then we have tangent as well. Oops. Tangent of X. So that would be adjacent. Here's tangent OA. That's the TOA piece. Tangent is opposite over adjacent. So B over A. So this is just a quick reminder of what we know. We're going to apply that. So the goal is with these several first examples here is figure out based on what we know from this image, these images, do we have the tools? Are these tools going to work in finding out all other missing pieces of this triangle? So in part A, I know all three sides. Is that enough information for me to determine all three angles? Well, I know that those three angles will add up to 180, but I don't know any of them, so I can't specify which one, what their measurements are. It's not a right triangle, otherwise we would see this little square. You can never assume a triangle is a right triangle, so I can't necessarily assume that's a right angle. It would have to be marked. So I can't apply any of my right triangle trig. So in this one, we do not have enough information. Either not enough info or we need more tools. We just can't figure that information out. All right, what if I have a right triangle and two sides of that right triangle. Can I figure out all missing pieces? I'm hoping the first thing you're thinking of is the Pythagorean theorem. So I know one side, I know the hypotenuse, and I want to figure out this base down here. So I'll just call this b down here. The Pythagorean theorem says that 4 squared plus b squared equals 5 squared. So a squared plus b squared equals c squared. That means 16 plus b squared equals 25. That means b squared equals, so I'm going to subtract 16 from both sides. That's 9, which means b equals, so I would take the square root of both sides. Square root of 9 is 3. So I know that I have this side down here. Now all I have are 3 sides similar to this. First example, however, this one is a right triangle, and that's going to allow me to find my other 2 missing angles here because I have trig ratios. So let's say I wanted to figure out this angle right here. I have all 3 sides of this right triangle, so I can use one of these trig ratios, sine, cosine, or tangent, based on where x is and based on the measurements of these sides. Whoops, I said b equals 5, but I meant to say b equals 3. Okay, so b equals 3. Okay, so here's x. 3 is opposite, 5 is hypotenuse. So if I want, I could go up here and use sine. I also know the adjacent side and the hypotenuse, so I could use cosine or tangent. I know all 3 sides. So I'll just use sine since I saw that first. So the sine of x equals opposite over hypotenuse, so 3/5. So if I want to get x by itself, right now it's stuck inside that sine function, so I need to apply the inverse to both sides. That would be inverse sine. So x is going to equal the inverse sine of 3/5. Now I'm solving for an angle measure. When you use your calculator to solve for an angle measure, it's really, really important that your calculator is in the correct mode. If you hit this mode button right here, which is on the very top of your calculator, it says mode. If you hit that button and scroll down, so watch my blinking. So you see it blinking on radian and you see degree next to it. Right now I am on degrees. I want my calculator to tell me how many degrees the angle is in. So if your calculator looks like this and the radian is highlighted in black, that means you're in radians. You need to arrow over and highlight in degrees. That's what we want. Once I'm there, now I can apply the inverse sine of 3/5. So on your calculator, make sure you know how to go through these processes. So inverse and then the sine. So second sine 3 divided by 5, and I get about 36.9 degrees. So x is about 36.9 degrees. And then my other angle, so let's just say I was calling that y. Now I have a couple options with y. We could do another trig ratio for y, or we could remember that all of these 3 angles add up to 180 degrees. So that's what I'm going to do. So I'm going to do 180 minus 90 degrees minus what I got for x, which is 36.9 degrees, and the result will be the final angle. So 180 minus 90 minus 36.9, and I get 53.1 degrees. So y is about 53.1 degrees. So I was given 2 sides of a right triangle and was able to find the other 2 missing angles and the other 2 missing and the other missing side. So with just the tools that we have so far. So let's go down and look at a couple of other examples. So right now, if I know 2 sides and the angle in between, do I have enough information to find out all the other info? So these 2 angles and this side. The problem is this is not a right triangle, so I cannot use any of my right triangle trig or the Pythagorean theorem. So with this one, it looks like we should be able to use some of this information, but not with the tools that we currently have. So we need more tools for this one. There is a way to do this, but we just don't have the tools yet. So we're actually going to revisit this one. This one looks pretty similar, except notice that what we have are 2 sides and an angle that's not between them. This one had the angle between the 2 sides that I know. This one has 2 sides and an angle that's not between them. Once again, this is not a right triangle. I can't apply any of my right triangle trig, can't apply the Pythagorean theorem, and I only have one angle, so I can't find the third. So this one, I feel like 3 pieces of information should be enough, but right now we just don't have the tools for that. We will come back to this. Okay, next down here, this is a right triangle, so I have a right angle, I have 30-degree sides, I have the hypotenuse. Right off the bat, I know that if this is 90 and this is 30, then this has to be the remaining amount when I subtract those two from 180. So immediately I know I can find this. So 180 minus 90 is 90, minus 30 is 60. Right away we know that angle. And then I could use any of my, now I have all 3 angles, I could use trig functions to relate the angles, these 2 angles with these 2 sides, since I know one of them. This one we can do. We have the tools for this. I'm not going to spend time doing it, but we have enough tools and could, with a little bit of work, find all that missing information. This one, 2 angles and a side knot between them. This is very similar to the one above it. It looks like we should be able to do it. It's not a right triangle. But I'm going to give you a little preview of what to expect, because this one is a good example to show you something. This is not a right triangle, but I know these 2 side angles, right? What if I took this vertex up here and formed 2 right triangles by drawing a vertical line? Now I have 2 right triangles, so it's splitting that base up, but I have 30 degrees, 90 degrees. I could find these missing measurements and then apply right triangle trig. So that's going to be the tool that we really look at today is, can we form right triangles within non-right triangles to figure out the missing information? So that's what we're going to do right now. All right, so we're going to move on. So flip your page over and we're going to look at problem 53. So problem 53 looks at 2 of the triangles we had on the previous page that I said we needed more tools for. So that's this one and this one. And now we're going to see if we can't combine some of these tools, be a little clever, and figure out some missing information. All right, so on part A, keep checking my timer because I want to make sure this video isn't too long for you guys. All right, so can splitting a triangle into 2 right triangles help us find missing information? I wonder if it can. All right, so do your best to take the vertex of this triangle and go straight down, and we are going to form 2 right triangles. So now we know this is 2 right triangles. Just a reminder that this 20 base, this measurement of 20 is the whole base. And we're going to need to keep that in mind because I've just split this into 2 triangles now. So the whole thing is 20. My goal is to find this opposite side of this bigger right triangle. I'm just going to call this side, I have 14, 20. This is the one other side I need. I'll call it X. And I have one angle, 60, and I want to find, I'll call this angle A, and I'll call this one up here angle B. So I want to find the measurement of A and B, my 2 missing angles, and my one side. To do that, it's kind of like a little puzzle. We're going to have to start with some of information that we don't necessarily want to find, but that information is going to help us find the others. The first thing is that I have 2 right triangles now, and I have this new side that's right here formed on the side of both of my right triangles. And that's going to be my connecting piece of information to help find this missing piece here. So this is H. If I can find the height of this triangle, then I can find the value of the hypotenuse of this right triangle. So H right here. Now, remember I have this 60-degree angle, this 14 on this side. So, and I want to know, you know what, I put H for height. I just don't want to get that confused with hypotenuse, which is what X is here. So just keep in mind this H stands for height of this triangle, not hypotenuse. Okay, so I want to find this value of H. I have a 60-degree angle. I know the hypotenuse of this smaller right triangle is 14, and I want to know the side. opposite. So I want opposite. I have the hypotenuse. So that should hopefully ring a bell for the sine function. So the sine of 60 degrees equals sine of 60 opposite h over hypotenuse 14. So now I have a relationship here with only h as the unknown. I can get h by itself by multiplying both sides by 14. So I would get h equals, and all I have to do is type in 14 times the sine of 60. Again, make sure your calculator is in degree mode, otherwise this is not going to come out with the correct value. So 14 times the sine of 60, I get 12.12. So my height of that, these two triangles that I formed is about 12.12. Okay, I'm just going to kind of underline that. Now, if I have this height and I want to find some other information here based on this triangle, remember I wanted the angle of B, X, and A. So think about how we are going to do that. So give me 1 second here. Okay, we're all set. Okay, so now I have this height. It's 12.12. So I'm just going to write that in there. 12.12. Now I have two sides of this small right triangle, which means I can get this third side. So I'm going to call this third side, this tiny little side right here, Z. I want to know Z. So 14 squared, that is the hypotenuse. So Z squared plus 12.12 squared. Remember this little right triangle, I can apply the Pythagorean theorem to now. So that would be Z squared plus 12.12 squared has to equal 14 squared. So I'm just going to crunch those numbers. So Z squared, 12.12 squared, whoops, 12.12 squared is 146, I'll just say 146.9. And now I'm going to subtract that from 14 squared. So 14 squared is this. And I'm going to subtract over 12 squared, or 12.12 squared. I guess I didn't need to do that. Oops. Minus 12.12 squared. And I get 49.10, so about 49.1. And then take the square root of those, and I'll get that tiny little side right there. So 49 square root of that, 7.007. So we'll just estimate that, we'll round that to 7. So if this little piece right here is 7, then remember the whole base was 20. Which means now I know the base of my larger right triangle on the right-hand side is 13. That is super useful because now, look what I have. I'm able to solve for X now, the missing side of my original triangle. So I have the missing side, and now I can apply the Pythagorean theorem on the big triangle to find X. So 20 squared plus 12.12 squared equals X squared. So let's write that. So 20 squared, I'm sorry, not 20, 13. So I'm using the Pythagorean theorem on this right-hand side triangle. So 13 squared plus 12.12 squared equals X squared. All right, so let's crunch these numbers. Sorry about the glare on the calculator. I'm trying to find good spot to put it where we can still see my paper. Okay. 13 squared plus 12.12 squared. Turn. Okay. So that is 315.9. 315.89 equals X squared. So now I just need to take the square root of both sides to get X, which is the missing side. Square root of that answer, about 17.78. 17.78 units. This isn't these aren't labeled inches, centimeters, whatever. So we just will put units. Okay. Now was a little bit of work. We had to do a few things on our way, but we finally have the missing side, the third side of this triangle, by splitting it into two right triangles and applying trig ratios. Now I just need A and B, the angle measures. I'm going to solve for this measure A. Once I have A, I can subtract 60 and A from 180 to get B. A is an angle in this smaller right-hand side right triangle. So that's why I chose to do A first, because I have the adjacent side and I have the hypotenuse now that I found X, and I have the opposite side. So I can use any of my three trig ratios. So I'll use, it doesn't matter, I'll just use sine. So the sine of A, remember sine is opposite over hypotenuse. So opposite 12.12 over hypotenuse X 17.78. Now that's the sine of A. I want A itself. So I have to undo sine. So I need to do inverse sine of this side, inverse sine of this side. So I need to do the inverse sine of 12.12 divided by 17.78. And I get 42.97, so about 43 degrees. So 43 degrees. All right. I have one of my missing angles. I have the one missing side. All I need now is that third missing angle, which is simple as doing 180 minus my other two angles, minus 60, minus 43. And finally, I have all missing pieces. Okay. I had to make two other triangles and do a lot of trig along the way, but we finally found our three missing pieces. Let me check my time. Okay, I'm at 22 minutes. So I'm not going to do these other ones. The point of this is we have a lot of tools. We're kind of combining them together. And what you're going to find in class is that this messy, next time I see you in class, this kind of messy, a little bit confusing and roundabout way of finding all of our missing pieces of this triangle can be streamlined into some laws that are used in trig that will be a little bit easier. And it has all to do with ratios when you form two right triangles inside of a larger non-right triangle. So we'll stop there. My goal for this is that you guys have been refreshed on our trig ratios, our tools that we have for working with triangles, because you're going to be using those a lot. Okay, I will see you in class next time. How do I stop recording?